Okay, so today we're gonna discuss about the hydrogen atom spectrum, right? So here, first of all, we're gonna take the discharge tube. So basically, hydrogen we need single hydrogen. So in the nature we cannot get the single hydrogen. We usually got H2 hydrogen molecule. So to get hydrogen from this, we need the discharge tube, right? So first of all, I'm taking here discharge tube. Okay, this is discharge tube. After that, I am connecting this with the battery, right? This is what battery, connected with battery. Here we have positive charge, here we have negative charge. Fine. So here in the discharge tube we have hydrogen, 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 hydrogen. Fine. And here this is the battery. So from the battery, charges are moving here. Fine. So when the charges move, that will break the bond. The bond will be breaked, right? So I can here write bond break and obtain hydrogen. Fine. Bond is break. Now we obtain the single hydrogen. Fine. Now here I'm going to show you one series. Like here I'm going to make the one electron, nucleus. Here we have shells, right? 2, 3, 4 and 5. Fine. Now let me tell you here that first of all, when the electron, like here we have the electron. So when the electron move, when we give the heat from heat, which source we will give? Heat, sun. When from the sun we will give the high amount of heat, so that heat can be UV heat, visible light, or infra rays. Fine. So first of all, we're gonna get the UV rays, right? When we give the UV rays to these electrons will move, and these electrons will be excited. Okay, these electrons will be moving here. These electrons are now excited. Fine. So now here the electrons are what? Electrons are unstable because they move to the excited state. This is what? Excited state. Fine. Electron move to the excited state. Now electrons are unstable. Now this electron wants to come down, so this electron will come here from this one shell here, from this one shell here, from this one shell here. But this, when we will pass the UV rays, this electron will always come on the K shell. This is the K shell, as we know. Okay, so K shell. Fine. After that, here when we give the light and visible light, okay, so when we put the visible light, so here UV have the high energy, so that's why it move, that's why it come down to be stable at the K shell. Fine. We will give the heat energy to the UV, when we give the visible light to the this electron, so this electron will come down because here electrons are unstable. Fine. When this electron will come at the L shell. Fine. This electron will come at the L shell. So here this is the L shell, because here as we give the low energy, this medium energy, this UV light have not higher not lower, medium energy. Fine. So medium energy, when move upstairs it become unstable, when it come down it become stable at the L shell. So from that we notice that L is one type of orbit and K is one type of orbit, right? Here we got the L shell. Fine. Now when in the infrared, this is basically the low energy. So here when we put the energy to this one electron, okay, I'm right here. We put the energy to this one electron. Fine. Here it become unstable. So it will come electron at this. This will come electron at, this is K, L, M, N, O. These are the 5 shells and more than infinity. Fine. So this electron come at the M shell. Because here this electron becomes stable at the M shell because of IR have the low energy. Now here we have another two things that IR, and here I'm typing IR have two types, IR near or IR far. Fine. So IR near is basically when the electron get excited, it become unstable here, so it will move at what, N shell. Fine, it will move to the N shell. So this is IR near. Fine. After that, when these electrons will be, this near electron will also come at the N shell. Fine. After that, this is wrong, N shell. After that, this IR far will come. Here we have another infinity. Here we have a lot of these are infinity. Fine, infinity. So it will come at the O shell, that is IR far. Fine. So these UV, VL, IR, these K shell, L, M, and these orbits were determined by different scientists. So I'm drawing here the table so that it could be quite clear to you guys. Fine. Okay. So here we're gonna write the name of the scientist. Here we're gonna write N1, N2. Now you might be thinking, what is N1 and N2? So yeah, N1 is the electron which are present here, and N2 when electron move to the excited state. Fine. So here, name of the scientist first, Lemon. Lemon was the scientist who said N1, the electron when it becomes the unstable, this electron come at the K shell. So that is 1. Fine. And the N2 means the electron will be coming from either 2 second shell, either third shell, either fourth shell, either fifth shell. Fine. 2, 3, 4, 5, 6, 7, and so on infinity. Fine. And second scientist we were having, what was the name? Bellmans. Fine. Bellmans gave about the visible light. He said that the electron will move up and it will come down in the L shell, means second one. Fine. And here electron will come from 2, not 2, this was the 2, will come from the 3, 4 and 5, so on. 3, 4, 5, 6, 7, so on. Another scientist was, let me think about it. Another scientist was basically Paschen. Paschen gave about the ER light. Fine. Paschen gave about the ER light that when the electron move up, electron will come at the M shell, means third one shell. Fine. So this will start from 4, 5, 6, 7, so on. Because when it move down, it will come from the 4th, 5th, 6th, and so on. Fine. After that, another was bucket. Bucket, he gave about the IR near. Fine, IR near. He said that the electron will, after to become stable, electron will come at the N shell, 4 shell, and there 5, 6, 7, 8, so on. This will come from the 8th one, from 8, 9, 10, and so on. After that, the last scientist was, his name was Funt. Yeah, basically P is silent, so we used to you call them Funt. Fine. So here Fun gave up the fifth, like we have the shells K, first one M, L, M, N, O, P, like that. So 1, 2, 3, 4, fifth was O. So the AR far was coming at the O. So this will be the further 6, 7, 8 further on. Fine. So this was how it became that the name of the scientist and how hydrogen atom we found that how much it emit the energy, and that's all. So yeah, let me tell you one more thing. Hydrogen atom is basically from the line spectrum. Line spectrum. Hydrogen atom is always from the line spectrum. Fine. And here some more points can be discussed. No, these are fine. Hopefully this is clear to you guys. In the next video we're gonna discuss about next topic. So bye bye.